Good morning. Today we will start with the next chapter, energy transfer and general energy analysis. Whether we realize it or not, energy is an important part of most aspects of daily life. The quality of life and even its sustenance depends on availability of its energy. Therefore, it is important to have a good understanding of source of energy, conservation of energy from one form to another, and the ramifications of these conversations. Energy exists in numerous forms such as thermal, mechanical, electrical, chemical, and nuclear. Even mass can be considered as a form of energy. Energy can be transferred to or from a closed system into two distinct forms, either as a heat or as a work. For controlled volumes, energy can also be transferred by mass flow, like your fluid flowing pump or a nozzle. Energy transferred to or from a closed system is heat. If the system is closed, there is no transfer of mass, then the form of energy transfer is heat, which is caused by a temperature difference. Otherwise, if there is a mass flow, or you can say otherwise it is work, which is caused by force acting through a distance, like the movement of piston in a cylinder is the work. High pressure gases put force on the piston and the piston will move. This is the work. So there are two types of interaction, either it is heat interaction or either it is work. We start this chapter with the discussion of various forms of energy and energy transfer by heat. We then introduce various forms of work and discuss energy transfer by work. We continue with developing a general intuitive expression for the first law of thermodynamics, also known as conservation of energy principle, which is one of the fundamental laws. Overall, in chapter we will introduce the concept of energy and its various forms, discuss the nature of internal energy, define the concept of heat and terminology associated with energy transfer by heat, discuss the three mechanisms of heat transfer: conduction, convection, and radiation. Concept of work, including electrical work and several forms of mechanical work. Introduce the first law of thermodynamics, energy balances, and mechanisms of energy transfer to or from the system. Determine that a fluid flowing across a controlled surface of a controlled volume carries energy across the controlled surface in addition to any energy transfer across the controlled surface that may be in the form of heat and or work. Define energy conversion and efficiencies. Discuss the implications of energy conversion on the environment. So in this topic here, we will study by taking example. This is a refrigerator which is connected to electrical supply, and this is your adiabatic insulated room. Inside this room, refrigerator is opened and it will work. It will take electrical energy. So we are familiar with the conservation of energy principle, which is an expression of first law of thermodynamics. Back from our high school and years, we are told repeatedly that energy cannot be created nor destroyed. So this means simple enough, but let's test ourselves to see how well we understand and truly believe in this principle. So consider this room here with the refrigerator whose door is open. You may even use a small fan to circulate the air in order to maintain temperature uniformly in the room. Probably the first thought that comes into mind is the average temperature of the room will decrease as the warmer room air mixes with your refrigerator. But some may draw our attention to the heat generated by the motor. But as we know, refrigerator does not work itself. It will consume electrical energy and the motor will work. So definitely motor will generate some heat and that heat will be distributed into the room. So after a lot of discussions or a lot of, you can say, analysis, we will come to a conclusion here. The conservation of energy requires the energy content of the room to increase by an amount equal to amount of electrical energy drawn by the refrigerator, because room is fully adiabatic except electrical energy is coming through out of the room through this wire, and which can be measured by an ordinary electric meter also. So the refrigerator or its motor does not store this energy, therefore this energy must be now in the room. So because motor will do work, whatever electrical energy coming into the motor, it had done work on refrigerator, so means that energy now is in the room not in the electrical energy but in the form of heat. One thing more to be noted, that the actually by energy conversion what is meant, the conservation of quality of energy, not the quantity. Electricity, which is of highest quality of energy, one thing is to be noted that electricity is high grade energy, and on the other hand the thermal energy, which is converted, which is a conversion of electrical energy into heat energy, is a low grade energy. Means that whatever the energy input to the motor of this refrigerator is your high grade energy, and whatever this heat is dissipated in the room is a low grade energy. So this is the difference. The graded energy is degraded here. So now if you ask to name the energy transfer associated with the operation of refrigerator, we will still have a hard time answering, because all we see is electrical energy entering the refrigerator and heat dissipated from the refrigerator to the room. So obviously there is a need to study the various forms of energy first. So next topic we will start with the different forms of energy. So there are different forms of energy as we have discussed: thermal, mechanical, kinetic, potential, electrical, magnetic, chemical and nuclear, and there some constitutes the total energy, which is called E of the system. So the total energy of the unit mass basis is denoted by E, and which is equal to E by M, where E is equal to sum of all these energies. Thermodynamics provides no information about the absolute value of energy. It is impossible to measure the absolute value of energy. Take example, if I say you are sitting in a room, so if I ask you what is your velocity, it is impossible to tell what is your velocity, because you are sitting in the room, and whatever your house, or you can say your city, it is on the crust of the earth, and earth is moving with some velocity. So if I ask you, you will say I am at zero velocity, so my energy is zero, my velocity is zero. But in actual sense, it is a very complex model. Earth is moving and you can say planets are moving. So there are different types of kinetic energy which you contain. So but no need to discuss what we discuss. We only discuss, we need not to go into the absolute value of the energy. We will only discuss the change of total energy, which is what matters in engineering problems. Thus the total energy of the system can be assigned a value of 0 at some convenient reference point. The change in total energy of the system is independent of the reference point. Take the example, decrease in potential energy of a falling rock, for example, depends only on the elevation difference, means from where to at what level the rock had fallen, but does not depend on the reference level selected. So the thermodynamics analysis, it is helpful to consider the various form of energy. Actually there are two types of energy. One is which we consider as macroscopic in the macroscopic group, another is microscopic group. Let's understand this. Suppose this car is moving, the macroscopic energy of an object change with the velocity and elevation. This car is moving, so whatever the velocity of this car is called, it is macroscopic, because it is a bigger level, you can visualize it. And whatever the energy within these molecules and atoms, or you can say material contain, that is microscopic. The macroscopic forms of energy are those a system possesses as a whole with respect to some outside reference frame, such as kinetic and potential energy. The microscopic forms of energy are those related to the molecular structure of the energy and the degree of molecular activity, and they are independent of outside reference frame. Thus the sum of microscope form of energy is called internal energy. So whatever the internal energy is called microscopic. The term energy was coined in 1807 by Thomas Young, and its use in thermodynamics was proposed in 1852 by Lord Kelvin. So the macroscopic energy we can see as a kinetic energy, which is equal to half mv square. You can find in this way the macroscopic energy. While now if object is present at some elevation, so the energy that system possesses as a result of elevation in a gravitational field is called potential energy, and this is equal to mgh. So this is, if you take for unit mass, potential energy is dependent on gh. So we have two types of energy. One is your kinetic energy, second is your potential energy. The rest energy, which is the magnetic, electric and surface tension effects, are significant in some specialist cases only and are usually ignored. In absence of such effects, the total energy of system consists of kinetic, potential and internal energy is expressed as. So energy is expressed as your internal energy, kinetic energy, potential energy. So these two energies we have discussed. The third one, which will complete the total, which will lead to your total energy of the system, that is your internal energy. So this is the concept here up to about the energy, that your total energy of system is the sum of internal energy of the system plus kinetic energy of the system plus potential energy, and internal energy is denoted by U, and for per unit you can divide by mass, so it will become small u, kinetic energy, potential energy per unit, and you will get this U plus V square by 2 plus ZZ. So most closed system remain stationary during a process and thus experience no change in their kinetic energy and potential energy. Most of the system you can neglect these two energies. Closed systems whose velocity and elevation of the center of gravity remains constant during a process are frequently referred as stationary systems. The change in the total energy of a stationary system is identical to change in its internal energy. So if there is a total change in energy, that can be reflected by change in your internal energy, which is delta U. In this text, a closed system is assumed to be stationary unless stated otherwise. So you can take example of a pipe here, where your fluid stream is flowing with velocity VA, and the area of this section is pi d square by 4, and m is the your density into area into velocity is the mass flow rate of the fluid, E is the energy in the fluid. So you can write here, first you have to find the volume flow rate. So volume flow rate is equal to this area into velocity, and multiply with density, you will get mass flow rate. Now you had the mass flow rate, and if you multiply this mass flow rate with the energy per unit, you can say this small e, you will get the energy flow rate, which is analogous to the energy. So some physical insight of internal energy is given here, as we have discussed the internal energy concept. But what is the internal energy actually is, a molecule have a molecule translation motion, molecule rotation motion, electron translation motion, means electron will move around the orbit. Then you have molecular vibration. Molecule at some temperature, they will just vibrate, they are not fixed at the position. So then you have electron spin also, electron spins around its you can say own axis. Then your nuclear spin. So the various form of microscopic energies that make up sensible energy. So internal energy is defined earlier as a sum of all microscopic form of energy. It is related to molecular structure and degree of molecular activity. So these all activities include molecular activity and can be viewed as sum of kinetic potential energies of the molecules. So to have a better understanding of internal energy, let us consider all these energies, which is translation, rotational, then you had vibrational and rotational. The electrons in atom rotate about the nucleus and thus possess rotational energy. So these are the totals, and they will all include and they will result, and the portion of the internal energy of the system associated with the kinetic energy of the molecule is called sensible energy. The average velocity and degree of activity of molecules are proportional to temperature of the gas, means whatever the energy these molecules contain, it is connected, you can see measure at the average temperature of the gas. Therefore at higher temperatures the molecule possesses higher kinetic energy, and as a result the system has a higher internal energy. So it means this internal energy is a function of temperature. If the higher the temperature, higher is the internal energy. The internal energy is also associated with the various binding forces between molecules of substance, between the atoms within the molecule, and between the particles within an atom and nucleus. The forces that bind the molecules to each other, as one would expect, strongest in solids and weakest in gases. If sufficient energy is added to these molecules of a solid or liquid, the molecules overcome these molecular forces and break away, turning into substance into gas. So this phase change is called phase change, and the energy related with this phase change is called latent energy. The same you have molecules have chemical energy also. An atom consists of neutrons and positively charged protons bound together by very strong nuclear forces in nucleus and negatively charged electrons orbiting around. The internal energy associated with the atomic bond is called your chemical energy. And then next is nuclear energy, which is related to the, you can say, your nucleus. The tremendous amount of energy associated with the strong bonds within the nucleus of atom itself is called nuclear energy. And the internal energy of a system is the sum of all the form of microscopic energy, but we hardly came across this nuclear type of energy in normal day problems, so we can simplify the equations. So this is up to here is about the internal energy and various form of energy like potential energy, kinetic energy, which are broadly classified into two categories, macroscopic and microscopic. So just like this video, subscribe my channel, and you can give a comment into the below section. Thank you for watching this video.